Introduction to handling game turns in Flutter. In any game, especially two-player games like tic-tac-toe, the concept of turns is crucial to the flow of the game. A turn is the interval of time during which a player can make a move. For tic-tac-toe, these moves typically involve placing either an X or an O within a 3x3 grid. The core gameplay revolves around the alternation of turns between two players, ensuring fairness and keeping the game dynamic and engaging. In modern mobile development, Flutter offers a vast array of tools and widgets that allow us to build interactive UIs with minimal complexity. One of the most common user interface patterns for such games is grid-based layouts, which provide an intuitive way to present the game's board to players. But building a functional, interactive game requires more than just displaying a grid. It's about managing game states, handling user input, and dynamically updating the interface. Flutter provides an elegant solution to this challenge with its reactive framework, which helps developers create real-time game experiences by using a combination of widgets like Container, GridView.Builder, and Sized Box. When building a game like tic-tac-toe, the first challenge is managing the turns. The game must know whose turn it is, whether it's player X or player O. Typically, when one player takes their turn, the game needs to update the grid to reflect their move, and then it must switch to the other player's turn. Flutter makes managing the state straightforward with its stateful widget system. Every time a player interacts with the grid, the game needs to update its internal state, indicating which player made the move and which square they chose. This update is typically done using a data structure, such as a list or array, to track which squares are filled and by which player. Every click on a grid square triggers a state change, and Flutter's framework ensures that the UI updates accordingly. The GridView.Builder is an efficient widget for rendering a grid of cells, and when combined with Container for individual cell rendering, it allows for both clean layout and responsive gameplay. The Sized Box widget, though not central to game logic, plays an important role in controlling the visual spacing between game elements, ensuring that the layout remains clean and visually appealing. This combination of widgets allows Flutter developers to implement the core mechanics of a turn-based game with ease. Through this simple yet powerful set of tools, you can efficiently handle the complex process of managing game turns, creating an enjoyable and responsive experience for users. Switching turns in the game logic. One of the core mechanics of any turn-based game is switching between players after each turn. In tic-tac-toe, players alternate placing their symbols, typically X and O, on the game grid. Handling this alternation in Flutter involves changing the game state each time a player makes a move. This can be achieved by using a Boolean variable or integer that toggles between the two players. For example, you might define a variable like isXTurn, which would be set to true when it's player X's turn and false when it's player O's turn. When a player taps on an empty cell, the game checks whether isXTurn is true or false. If it is true, the game places X in the tapped cell, and then the value of isXTurn is switched to false, signaling that it is now player O's turn. Conversely, if isXTurn is false, the game places O in the tapped cell and switches the turn back to player X. This alternation of turns continues until one player wins or the grid is filled. The turn switching logic is fundamental to keeping the game fair and ensuring that each player has an equal opportunity to participate. Managing game turns also involves keeping track of the current state of the grid, ensuring that players cannot make invalid moves. This means checking whether a cell is already filled before allowing a move. If a player taps on a cell that has already been filled, the game should ignore that tap and wait for a valid move. Furthermore, once a player has made their move, the game's UI should update to reflect the new state, displaying either X or O in the appropriate cell. Switching turns in this way ensures that the game proceeds smoothly, and that players are always aware of whose turn it is. State management and its importance in game turns. State management is one of the most fundamental concepts in Flutter, and it plays a pivotal role in building interactive applications like games. Games, by their nature, have a dynamic state that changes based on user interaction, such as when a player makes a move or the game reaches an end condition. For tic-tac-toe, this means tracking the game grid and the alternating turns of the players. Without proper state management, it would be impossible to correctly update the grid, switch turns, or check for victory conditions. Flutter offers several ways to manage state, but for this purpose, the most common approach is using stateful widget along with setState. Understanding how state management works is essential for creating a smooth and reactive user experience, and it allows us to break down the problem into manageable pieces. When creating a tic-tac-toe game, the game state is usually stored in an array, or a similar data structure, that represents the 3x3 grid. Each element in this array can either be empty, marked by an X, or marked by an O. The challenge lies in updating this array when a player makes a move. When the user taps on a cell, the corresponding element in the array is updated, and then the turn alternates between the two players. To ensure the UI reflects these changes, Flutter provides the setState method, which is used to notify the framework that the internal state of the widget has changed. Once setState is called, Flutter rebuilds the widget tree and updates the UI to reflect the new state. This is crucial in a turn-based game, where the interface needs to update quickly after every user interaction. Managing the state also involves tracking whose turn it is. Typically, you would use a simple Boolean flag or an integer that toggles between two states. For instance, if his X turn is true, it's player X's turn; if his X turn is false, it's player O's turn. This flag would be checked whenever a user taps a square on the grid. If the square is empty, the game updates it with the current player's symbol and then switches the turn. A key challenge in state management is ensuring that the game correctly responds to user input and doesn't allow a player to make a move on an already filled cell. To handle this, the game needs logic to check if the selected cell is empty before updating the state and refreshing the UI. Flutter's declarative nature makes it particularly well suited for such dynamic state management. Using a combination of stateful widget, setState, and proper checks on the grid state, you can ensure that game turns are handled smoothly. Handling user input with gesture detector. Handling user input is a key part of building interactive games, and Flutter makes it easy to manage taps and other gestures with the gesture detector widget. The gesture detector listens for different kinds of user interactions, including taps, swipes, and long presses. For a game like tic-tac-toe, the most important gesture is the tap, as players will be tapping on the grid cells to place their symbols. To make each grid cell interactive, we wrap each container, representing a grid cell, in a gesture detector. The onTap property of the gesture detector listens for tap events, and when a tap occurs, it triggers a callback function that handles the logic of the game. When a player taps a cell, the callback function checks if the cell is empty. If the cell is empty, the game updates the state by marking the cell with the current player's symbol, either X or O. After updating the cell, the game must switch to the next player's turn, so the function toggles the state of the turn indicator, for example, from his X turn to his O turn. This ensures that the game alternates turns between the two players. The gesture detector is a powerful tool because it provides a simple and declarative way to handle user input without requiring complex event management systems. It allows the UI to respond directly to user interactions, making the game feel more responsive. In addition to managing the game turns, the gesture detector can also be used to detect other gestures, such as long presses, to add additional functionality like a restart button or other game features. The flexibility of gesture detector makes it easy to extend the game's functionality without adding unnecessary complexity. However, while gesture detector handles the gestures, the game logic itself must be carefully implemented to ensure that players can't make invalid moves, like clicking on a cell that has already been filled. The game state should be checked on each tap, and if the cell is not empty, no update should occur. This ensures that players can only interact with valid grid cells, and the game remains fair and enjoyable. Leveraging container for individual grid cells. In Flutter, the container widget is highly versatile and is often used to style and position individual elements within a layout. When building the grid for tic-tac-toe, each cell in the grid needs to be visually distinct and clickable. The container widget provides an excellent way to encapsulate each grid cell and give it a customized appearance. Containers allow you to define the size, padding, decoration, and alignment of each cell, which makes it a perfect choice for building the UI of a game board. Each container in the grid can be styled to represent either an empty space or the X or O placed by the players. For example, you can use the decoration property to add a border around each cell and give the background a different color depending on whether the cell is filled or not. For instance, a cell could have a white background if it's empty, a blue background if it's filled with X, and a red background if it's filled with O. This immediate visual feedback makes the game engaging and easy to follow for the player. Additionally, Container allows for easy customization of cell sizes. The size of each grid cell can be adjusted to fit the overall layout of the game board, ensuring that the game looks great on various screen sizes. This can be done using the width and height properties or, for more flexibility, by using a sized box within the container to further control the cell's dimensions.